I'm here basically to give the fabricator's perspective. WWAFCO in our San Angelo plant, we have fabricated triple I-Girders on 2 different projects in Texas now. The first one, which is primarily most of what I'm going to talk about here, was the San Antonio project. The steel here, which I've got to say now, sorry Ronnie, but it's from best fabricator in the United States. And biggest is true. So anyway, so here we're. Back up. We're here to discuss 4-sided boxes versus triple I-Girders. And I'm going to say, well, the fabricator is what we like and what we don't like. But since don't like is such a hard term, I'll change that to say what we would rather not see. I'm going to talk about the problem areas. What's easiest to fabricate between the two. And a couple of unexpected things that came up that when you first look from estimating to detailing to fabricating, problems that you don't really expect. Okay, so as we talked about earlier, a lot of this stuff's going to be the same thing we've been talking about all day. 4-sided boxes are non-redundant, and because of that, you have to follow the AWS fracture control plan. Basically, it's still the quote fracture critical as far as fabrication, materials, field inspection. And some of the things you would rather not see, let's get into those. And the very first thing you don't want to see is, if you don't have to, from fabricator point, is the complete joint penetration welds. Those groove welds with all the preparation, all the welding, and then the testing of the welds. As you can see here on the far right picture, it's close up of a bottom flange with the web coming down on the outside, and then the backing bar. So basically using backing bar for that groove weld. You think, well, that's not that big a deal, but well, just the aspect of putting that little small bar for the length of the girder, trying to keep that thing straight, is hard, because that thing's going to have all the heat on it. It's just going to want to wobble. And then you've also got another problem area. Things you'd rather not see, is we talked about painting inside the boxes. When you paint inside, let me go back to that. When you're painting inside the box, basically what you've got to do, you've got to, before you assemble this girder, you've got to go through there and blast it. And then we normally put the primer everywhere except for where the weld's going to go, and we leave that blank. So what that does, it saves you, once the box is being put together, it saves you from having to go back and paint the whole thing inside of the box. Now all you got to go do is go back and paint where the welding was done. Okay, we're going to get into problem areas. Once you get a 4-sided box, you always want to have all your welding, you want to avoid overhead welding. Everything you want to do is down flat. So you've actually got to roll your boxes as you're doing it to go from the bottom flange to the top flange. And as you can see, this is a pretty big box. So every fabricator's got their own way of wanting to roll these boxes. Most of them come up with some kind of frames. Here we've got a rectangular frame. Some fabricators I've seen have an actual round frame that'll just roll it over. But either way, just rotating that box, think about the hazards and what's going on in the shop. That's pretty heavy, pretty demanding job. And then the problem areas, which we just talked about earlier, working inside the 4-sided boxes. You have the occupational confined space standards that you got to worry about, that you got to keep track of. With that, as I'm talking about it, look at this box. That's a pretty big box. That's pretty tall, but it's also pretty long. So when people are working down into it, the next couple of pictures you're going to see, you'll see how far away they actually are. But with the what you have to contend with four-sided boxes like this is you have to have extra employees. You have the people working inside the box, but you've also got extra employees that have to keep track. They got to watch out what's going on, make sure they got to monitor the air quality. They got to watch out for the heat. You know, was mentioned earlier. You don't not only have the heat from the welding, but the preheating of the steel before the welding. And then there's also the noise. If you have some voltage going on in there, you got sledgehammers hitting on the drift pins. You got the bolting and how loud that is. Then you got the grinding. It gets really loud inside those boxes. So here's a couple of pictures. They don't show up as good as I wanted them to, but picture on the left, basically you're looking down that large box and you can see down on the bottom the tubes. Basically that's the air ventilation system being blown in there to reach down to get to those employees. And that on the right is how far down they really are when you're looking from the end of the box. And like I said earlier, this is a big box. So they're working inside of it. You see, we've got 4 employees in there. Now what happens when you get to a small box? This box inside, 3'3" by 3'5". It's in our Colfax shop right now. Think about 3'3". It's right there from the floor. So 3'5", a little bit wider, add 2 inches to it. So you can imagine having to work 30 feet down. You're crawling on your hands and knees the whole time. Or you're laying on your side trying to do some welding or bolting. So it's not very comfortable, and I'm glad it's not me. Okay, so we're going to get into problem areas. And these problem areas, you know, they talk about the grading. You think grading, oh, that's not that big a deal. So the estimator gets it. He prices the grading out, as the FRP grading in this case, and we price it out. But the other project, which was up in the Dallas area, it had a galvanized grading on it. So 2 different things. But anyway, what we're finding out is that from a detailer point, we made a mistake of, we're fabricators, we're bridge fabricators. We don't deal in grading. So we had our detailer detail the grading. Well, what it does, it forces your detailer to spend a lot of time researching, trying to figure out what kind of grading do we get? Does this meet the spec? Does this not meet the spec? Well, like I said, it ended up being problems with, and sorry about on yours, but on the FRP grading, we found out that what we wanted to get, even though down here in the bottom right corner, you'll see the spec. That's what right off the design plans. And you think, from our estimating point, that's enough information to get a good price. But when we went to try to get the grading, we could not find the grading to match that. We ended up having to go through a couple of different suppliers trying to find something right with several RFIs, and we finally got it straightened out. But it ended up being a whole lot more hassle than we were expecting. So when we got to the other project, and it had the galvanized grading, we actually, first off, we detailed it wrong because the design plans on it didn't say which way the bearing bars had to go. And like I said, we used our structural steel detailer to get the grading, and we've since learned that, hey, from now on, you go straight to a grading supplier, have them make their own drawings, have them decide what to get. But so this one makes sure that it would be helpful if the designers did a little bit more research on it and a little more specifics on what we have to do with those, what we have to furnish. And then looking at the fasteners, because of the fasteners, which I'm getting ready to get to in a little while also, fasteners have turned into a big problem for us. Okay, what's easier to fabricate? You guys know this already. The triple I-girders basically are simple girders, plate girders. We fabricate those every day of the year. The assembly is easy. You have to fill it welded, flange to webs. You don't have to worry about any complete penetration welds. You don't have to worry about rolling the girders in the assemblies for get them down into the proper position for welding. Everything's CNC drilled, the diaphragms, the stiffeners. You have the open flanges, so you don't have to worry about the confined space restrictions. And the same picture you saw a while ago. Basically, the triple I-Girder caps are simple to fabricate and assemble. They go down, even when you have it closed on the top, it's still open on the bottom, so you don't have to worry about that confined space. I won't get into this since we just did. Then we're going to get into another one of those unexpected discoveries. So the very first thing you'll find out about this, that you expect this thing's going to be heavy. He called them light. They are light compared to concrete. But when you're in the shop, you put 3 girders together, they suddenly become very heavy. Because your shop's crane limitations, you may have a 100-ton crane or whatever. You start putting 3 girders together, and they can easily exceed that 100 tons. So you're being forced to use multiple cranes in the shop, or if you're taking it out of the shop, multiple MyJacks. You know what a MyJack is? It's a crane, it's a movable crane on the bottom. This is the end that he talked about just a few minutes ago with no opening on it. Okay, like I said, the unexpected discoveries. Grading, they actually became our biggest hurdle. Not on the San Antonio project, but on the other project more. We actually came in one place, the picture on the right, where the detailer is going through making all the grading. You got to take the grading, it's supposed to go web to web. You think, why can't you just have it go just overlapping the inside of the flanges, and all they got to do is cover that opening between the 2 edge flanges. But it becomes a trip hazard. If you're walking down the flange and you got that little grading sitting 3/4 of an inch or an inch up, and you go hit your foot, you're going to fall. So you make the grading go all the way edge to edge. And then here, the sole plates, the bearings that are put on there, we actually detail the grading to go on the bearing. And it's already closed. So what do you need the grading for? The clips, most of the grading has, I don't think I have a picture of a clip. I regret putting that. But most of the clips, if I got one right here. There's one. If you look at this clip, I'll get back to this frame in a minute. You see the straddle clip on top. Basically, a bolt goes down through it and goes down to a little G-clip, excuse me. And it's just like a clamp. All you're doing is tighten it down. But so you'll see that right here, you have no place to put that clip over the bearing. So we actually sent an RFI out just to leave that piece of grading out. Okay, standard clips. Okay, your standard clips, they really come available. They're only thinking about, mostly it's structural work, catwalks and things. So the clips come in like 3/4 inch, 1.25 inch. Basically, you're just going to tighten down. Well, what happens on these girders? You got the 2.5, 3-inch flanges, and then you've got the splice plates for the field splices. You got long girders, you got field splices in them. So we found out real rapidly we couldn't find the clips to be able to strap this grading down. So we went through several different options, back and forth, trying, guys in the shop trying different things. You can see you can kind of tell by this picture right here that the little straddle clip on top is not sitting flush. Well, that's because the bearing bar got in the way. So on one side of the flange, say girder number 1, you line it up where you can get that saddle clip to line up with the flange. You go to the next adjacent girder, and it doesn't work out. So we had to come up with different things to do there. Like I said, because of the thickness. And in this particular case, I think we ended up actually sending an RFI out to use some threaded shear studs or threaded studs, and that way we can just bolt the clamp to it. I don't think that's been answered yet. We've been fighting this battle on this one for months. No, it's not. Yeah, you are correct. I'm glad you said it. This is the other project. But like I said, this our biggest hurdle on this whole project, you think, oh, this is a huge project, long, heavy. This was the biggest problem. Okay, so little commentary on the complete assemblies with the long girders. Like I said before, sometimes these things can get easily over 100 tons. So what it does, it forces a field splice. So you put the field splices in there, and then what happens with the field splice, you get it out in the field. The erector's got two sets of 3 girders together, and he's got to block everything up, make sure he's got it set to the proper elevations, bolted together, and then pick it all up. But there's also another option, which I think on the first job that Ronnie did, you have the option of trying to reduce that weight and keep them from to not have to, or put it this way, to eliminate the field splice, is ship 1 of the girders loose. You can shop bolt 2 and have 1 loose to reduce the rate, or you can ship all 3 girders loose. You know, a little more work for the guy in the field as far as actually having to put things together, but you can ship it that way. And for the guys in the shop, for example, I use it at the bottom. You had a 120 foot long triple I-Girder, total weight, roughly 150, 155 tons. So you're thinking, okay, we've got to put field splices in it. But if you broke it down, you just ship the girders loose, 350 ton girders, no field splices. Really, it's the contractor's option. What does your erector want? So you got to get that straightened out beforehand, because that's all going to be included in the price from the fabricator. Observations. What do we like? Man, don't really have to answer that one, do I? But much rather have the triple I-Girders. And why? No fracture control plan to worry with. No rolling of the assembly for the welding. No complete welding, complete joint penetration welds. And then no confined space problems. Nice and easy. Everything else has been talked about before. Any questions? Jason?
With the grading some more. It looks like a water and debris trap. Where these are redundant structures, you are not required to do arm's length inspections. So I wonder, was it ever talked about just not putting the grading in there? And if on the off occasion you needed some kind of special inspection, you put something temporary?
The grading is to keep the birds.
Well, oh, that's
my understanding.
What's worse, the birds or the debris?
Good question from the world's greatest.
We'll work on it.
He makes the steel. He doesn't worry about where it goes. No, I'm just kidding. More questions? Yes, sir.
How much of your fabrication time is just in the all the places?
I can't answer that. My plant manager is not here. He was supposed to be here, but okay, we'd rather bolt those diaphragms in there as opposed to put all the complete penetration welds from the boxes. And that one did have a lot of bolting. So like I said, if it comes down to the weight of that, whether we put a field splice in there or the guy in the field putting the girders together, that's a lot of, if he puts the girders together, he's got a lot of bolting of those diaphragms, but it's easy bolting. It's not like you're having to put together a field splice, which is a little bit more difficult.
Most of our we had some holes that we specified as oversized and some that were standard holes. And The reason we had is we were worried about the columns. You guys, I think the our line is 8, we used to get holes, the holes was everywhere. And I'm curious, what was that about? We did slopes and all that stuff.
I don't remember that one, what, right offhand, but,
It's a little problem.
okay. One of those closure plates on top.
I think that's what it was.
It may be because what we did there, I think that we had your girders in assembly, and if you have the holes in the outside plate, you used to use those holes for a template to drill down to the flange. So you don't have to worry about any.
Yeah, so it's kind of like a template.
Okay, that's correct.
All right, thank you.